Okay, so derivative of a quotient of function, which we can also call quotient rule. Okay, so quotient rule has to do with division. It has to do with division. That is what quotient rule is all about. Okay, so if you look at what you have there, if you look at it very well, you will agree with me that if y is equals to u all over v, that is division, the division format. So forget about all of this. You can look at it, the proof. You discover that the formula to use, your dy ds will be equals to v du over ds minus u dv over ds, all of them over v square. So this one is saying that keep v, differentiate u, minus keep u, differentiate v, all over v square. Okay, all right, so we are going to have a similar example. If y is equal to sine s over s square, so this function take a pattern of division. So anytime you take a pattern of division, what do you use? You use quotient rule. But if you take a pattern of multiplication, you use product rule, which I've already explained in my previous video. Okay, so can you try it? Yes, having learned product rule, you can actually try it. The answer is this. Meanwhile, let's do it together. Okay, you can decide to pause the video and try it yourself before looking at my own. Of course, the upper one will be our u, the denominator will be our v. Okay, so what do? The principle says that, or the quotient rule says that, start with v, keep v, differentiate u, minus keep u, differentiate v, all over v square. So you can write this down somewhere. Write it down somewhere so that you can be looking at it while I explain. Okay, so now this is our u, sine s is our u, s raised to power 2 is our v. So the principle says that we should keep our v, then differentiate u. This is our v, we keep it as s square. If you differentiate u, differentiation of sine s is cos x. Okay, then minus, this time around, keep your u, differentiate your v. So by the time you keep your u is sine s, that is what we keep here. Then we differentiate our v, which is s raised to power 2, which will turn to 2s, all of them over v square. So this is our v is s raised to power 2, so this is s raised to power 2 all square. So we do a little kind of expression here. We have our s cos square, cos s, s square cos s, minus, if you use multiply 2s times sine s is the same thing as minus 2s sine s, all over the power multiplication. Law of indices, power can multiply power, turns to s raised to power 4. And then if you look at it very well, you have s here on the numerator, you have s here too. So this s raised to power 4, you see, one s can strike out here, one s can strike out here, one s can strike out here, so it reduces them with one s. So you are left with here the s raised to power 2 become x. Here the s here is gone, all over s raised to power 3, because s can reduce each of the s in each of the term. All right, so attempt this example. Y is equals to 5 raised to power e all over cos s. Okay, so remember our u is our 5 s raised to power, our 5e raised to power s. Our v is our cos x. And what is the principle says? Keep v, differentiate u, minus keep u, differentiate v, all over v square. So if this is the case, so what do? You are going to have, we keep our v is what? Our v is cos s. We keep our v, differentiate your u, your u. If you differentiate your u now, you are going to have is the same thing. 5 raised to the power e 5s 5e raised to the power s is the same thing as differentiation of it is in the 5 e raised to the power s. Then minus, keep your u is 5s raised to the power s, 5e raised to the power s. Then differentiate your v is cos s. So if you differentiate cos s, you are going to have minus sine s. So do your normal algebraic process here. The common between them is 5 e raised to the power x. So 5 e raised to the power s can be pulled out. You are now left with cos s. Then this minus times this minus change to plus. So you have sine s here. And then all over cos s square. Okay, cos s square. Alright. Now, why is it cos s square? Because here is v square. And our v is cos s. So cos s all square is the same as cos square s. Alright, so this is what you have here. Okay. Then we have more examples. If y is equal to sine s all over cos s. Now I'm not going to explain this. You're familiar with this trig value, so look at it gently. You can pause the video to look at it. You can pause the video to look at what I'm showing you. Okay. Well, now I have another little assignment for you. You can pause the video at this point. So find the derivative of each of these terms here. Alright, maybe you've tried it and you cannot get it, or you can get some, you can't get some. So this is our values. They are expected to be in your head. Okay, so they are expected to be in your head. So look at this. Remember this product rule and quotient rule here. So these are summary. Okay, you can try these examples, a lot of them here. Pause the video and try them. Okay, so peradventure you can check your answer. They are solved here. Look at the solution of them. Okay, you can pause the answer